Hi guys, so today I'm absolutely buzzing about this. Today I'm with Power Gas, going through a plant room in a hospital. This type of work's brilliant. Get into it. It's completely different. You gotta know about electrics, thermodynamics, system balancing, system design, mechanical design. It's absolutely incredible. Can't wait for this.
Those gas detectors are interlinked, so we've got them at high level as well. So they're right up the top there, because obviously methane's lighter than air. That's the point of this being.
One bomb inside over the water and just anything around that as the rest of it.
Yeah. That's down to condensation. Condensate, yes. Clean all those up. See, what we'd usually do with these are quite clean. If they run on oil for any length of time, the strutting will be a lot thicker, so we'd end up getting the tube brushes down and brushing them out, but we know from experience that these are okay. So this is, you look at the amount of tubes, so we've got one pass down the bottom, comes down the first circle, goes down the second circle, and then back up the flue. But that lock nut there, we've undone that one to pull the door open. I know when we go to put it back in, we'll check that nut probably half a turn further, so it'll tighten up a little bit tighter this year.
Okay, okay.
A major, we do these on a quarter, so this is the main boiler seal. If you look in there at the end of the burner, that's the flame plate. That mixes you, so you've got the swirling motion that gives the gas and air the mixture, so it gives, when you look at them burning from the other end of the boiler, you'll see the swirling pattern. Rating, gas in kilowatt, we rated from 1500 to 7,500. So that's 1.5 megawatts to 7,500 megawatts. These got a turn down ratio, so 7.5. So these are a 5-to-1 turn down ratio. That means at full demand they'll run at 100%, 7,500, but the 5-to-1 means it'll turn down to 20%. So the boiler can run at 1,500 kilowatts.
So it's like a heat,
because you always need, the boiler needs sizing to the minimum demand.
So this is the control panel for the boiler then? So this is like
So fuel 1, gas, fuel 2, oil. And this is just a description of what's happening. So that's showing the green light there, showing this flame sensing. That's your HT. That's just showing you your gas valve position, what's happening when it's doing its test. If you look on gas valve, so when this is connected up, gas comes in there, you've got a gas valve and a gas valve, and all they do is open and close. And they will gas prove that they are working. So initially, gas will come in there, that will open, gas will come into that chamber there, that one will close. That pressure switch there will then determine whether this one is working correctly, because if it's not, that seal's gone, that pressure will drop because the gas will leak into the combustion chamber. So that's how it proves that it's gas soundness tested.
But how does it know that it's lit?
No, that's separate. This is just gas proving.
This
just proves that the gas valves are shutting down. So you've got a massive volume of gas, 120 millibar, running on 4-inch pipe. They need to make sure that these gas valves, when they are in a shutdown situation, gas isn't leaking through to the combustion chamber. So obviously you've got risk of explosion. So it's called gas proving. 2 gas valves, gas pressure switch checking the incoming, gas pressure switch, checking the chamber in between the two gas valves that this is not leaking.
Oh, I'll get you now. Yeah, yeah.
Yeah, going fast. That there, that modulates the flow of gas. That is just a flap.
Okay.
It's an actuator that will proportionally open and close. That's your pilot gas. So that's just little solenoid, preset to whatever pressure, come here when that's open, lets it go into there for a pilot light.
Brilliant.
The pilot light on that is probably 40 kilowatts. So oil pressure comes in there, fixed speed on that.
Yeah.
So that will just rotate, and all this does to adjust the oil, the same again, it's a proportional valve. That there will get a signal on the CAN bus to say, right, I need to open up proportionally to whatever demand we've got, and that will relate to a pressure showing on that gauge.
Yeah.
And then for flame detection, input ionisation fluids, got a UV light,
Oh.
a UV sensor, sorry.
Photocell.
Photocell, UV
Yeah.
sensor, photocell. So that will look for the UV coming off the flame, ultraviolet light.
Okay.
It'll sense that. If it doesn't sense that, it knows it's not lit and it'll go to a lockout.
So here you got two solenoids. What are those two solenoids for?
It's due to standby, so it's like they'll just let it in. So we've got oil pressure coming in there through that, and then it's fail safe because you have to have them both open. So that just flows through there, and that there it's restricted there. That is its restriction to give it proportional.
You need to have the efficiencies absolutely spot on.
Yeah.
You're going to be, using a lot more gas than what you need to.
So that is connected to the control panel, and that will alter the ratios of the gas to air. To get it, we are looking no less than probably 2.2% oxygen. Anything less than that, you start getting incomplete combustion, sooting. So we try not to risk it any lower than that. So ideally, they always between about 2.5 and 3 on the gas.
What's that?
So this is just detecting the water levels. So up there, obviously, we need to make sure we've got water in the boiler at the right pressure, because obviously if we haven't, we've got potential to the boiler to destroy itself. So we've got low water levels, low water level sensor in there, and low pressure. Low pressure sensors up there. So we can test when the power's on, we can test that, and those lights should illuminate.
These will pump in and out of the vessels.
Yeah.
And then these will pump in and out of the system to match the pressure. So the boilers keep running, pumps keep running. So these are for your chemical dosing and water level. Ready to be brought into the system. In there, set it to the lowest thing, so it's just the tiniest bit open. We have these all around the hospital for heating as well. But yeah, there's no moving parts. It's just that you get out. That's pumped up into the system right now. Current pressure, current water level in the vessel, solenoid valves there and there, dumping out of the system. Knowing when it's topping up the tanks. List of alarms, warnings. Flange off here, and there'll be a big mesh strainer inside, catches all the crap from the system. We pull that out, either replace it or give it a wire brush to clean it up. Usually it's not too bad, but you know, it's just a feature of the system. Make sure the pumps.
Diesel generators then?
So these run off diesel, yeah. So light oil, red diesel.
Yeah.
So you go around in here, look, you'll see. So V16, radiator,
Yeah.
air cooling, day tank, that's the oil tank for your day tank. Outside, a bulk storage tanks, 120,000 litres that pump up into these.
What's that?
Intercooler.
Oil cooler, yeah.
Yeah, so if you look at all these fire wires, the drop valves, mercury switches monitoring drop valves.
Oh yes.
So you look, every now and again you'll see a thermal link on the drop wires. See there, look above the generators, soft solder links, so there's a fire above it, they'll break, drop the valves.
Guys, what's that then? Is that...
That's the fan, radiator fan. If you look there, them louvers there, when these kick in, those louvers open up like a wind tunnel in here. So all that opens up at the back of there and it's all blowing through. Like I said, you know when you look above, the 6 flues, all these 6 flues are in here. So that is that's your dynamo, that's
Yeah.
the generator and there's the engine. There's your batteries to start it.
Oh wow.
You want one of those to be carried. Oil comes in there, goes on that pipe there, and down in. That's an overflow pipe there, and that's the dump pipe. So if there's a fire, and this fire breaks, that will drop, and that will dump the oil on that big pipe there back to the tanks outside.
Okay.
So you haven't got the risk of
Yeah.
even more fuel in the fire. These are bundled tanks, so Bund is 110% of the volume of the tank, the
Yeah.
oil capacity. We've got 5,000 litres stored in there. We've got the Bund alarm checking if there's any oil in the Bund, which indicates that the main tank's leaking, overfill, too much oil in it, and all that will kick the pumps out downstairs. And level sensors there showing the level. This is what's called a generator hall. It's rows of generators. You've got HV and LV, low voltage, high voltage.
How often do these function then?
Do it, I think it's a 2-weekly test.
Yeah, 2 weeks.
Wow, this is from the boilers.
These two are from the boilers. This is boiler fluids. We've had this water in there and the flashings leak. There's twin wall, so it keeps cool. And that goes up 6 stories. I mean, we're on probably the 2nd or 3rd story now, and it goes up 7 actually.
Do you do any form of, and it sounds stupid, any form of spillage test on these?
Yes, we'll check. Well, it's just checking that the burner is working correctly. So the air pressure switches are working. Saying, I showed you the mechanical ventilation.
Yeah.
So that's got the air pressure switches on there.
So you wouldn't check for leaks or anything on this then?
Visual,
Okay.
and then check the termination. Like I say, this was pointed out. This leak here, this was pointed out, and it was inspected, and it was the flashings on the roof. It got contaminated and deteriorated. The refrigeration units. The back there, and there's another same at the back of these.
Wow.
Right, if you look at these pumps here,
Yep.
these are the new type of pumps with no bearings in them. These replace those.
Wow. Yeah.
And if you look at these, that's running at 3,300 RPM and it's only pulling 5 amps. Which doing 250 kPa at 5 litres a second. And when you look at the data bags of these, they're a comparison.
Yeah.
And they'll be 18 kilowatts over. What you class an unvented cylinder on.
Oh, so these are invented cylinders.
Similar thing, yeah.
So has that got hot water inside?
Yeah, so there's your coil on that, off the heating, and the outside side of that is your potable water. And there's the expansion vessel.
With the diaphragm in?
Yes, that's got an air bladder in there.
Okay, right, next thing. Stratification anode, where's that magnesium rod? Is there one of those in
No,
here?
you don't use anodes in these. So destratification pump, that's that.
Yeah.
So that keeps your circulation in there in case no water movement, so you don't get the destratification of
Yep.
temperature. Up there, you can see them all. Look through pressure relief valves or your discharge valves. And so that's pressure relief valves, and up there, if they were happen to ever fail, that's a burst disc, that one. See that one there with the green flange
Yeah.
on the top of it? That's the burst disc. Showing you.
Yeah.
These are the bigger version of these, so the control is separate to the pump on these, because these are a bit bigger, the pumps are a bit bigger, but it's the same scenario where if you get a lot better.
Is there anything on this to stop it against scale or attacking the tank?
No.
Like a magnesium rod, nothing? Okay.
There
Yeah.
is classed as a dead leg. So it's very difficult to get around that. The only way you could do it is you have a flow-through vessel.
Yeah.
Flow-through vessels, they don't make them that size. And I think that will be the next step in manufacturing and technology. Potable water, secondary return pump.
Okay.
So if you look again, same source controller. At the minute, that's drawing 5 amps, and that's circulating the water for 2 towers. And it's only drawing 5 amps, and that will keep, so secondary return, potable water, so it keeps constant water temperature and potable hot water all the time.
Bronze and
Yeah. Stainless steel.
stainless steel. Wow.
So what you'd expect, the air check valves,
that's a check valve.
Data for these new pumps now, everything's web enabled.
So you can log in on
all
a
the
phone.
information. Curve, the status, all the parameters, are all set. The web interface.
That's amazing. Yeah.
So this is what I do. I set all these set points and stuff. I mean, you can have like a quadratic pressure, so quadratic pressure and flow at the same time, all working together to achieve an optimum. It's like I say, parallel, so multiple pumps working together, or you can have them on the digital inputs, everything.
That's the old fashioned type. We've got the new one over there that's all cranked up ready to install. So if you look at these, it's the same scenario again with still paint. So all it does, water in and out of that. The newer ones, I've got to mention, they have what they call deaeration on them. So even if the water in the tanks isn't being used to top up and reduce the pressure in the system, every now and again it will let water go into the tanks. At the top, there's a dip tube at the top. Instead of one inlet and outlet, there's two. And the dip tube will let the water out at the top, and any micro bubbles in will permeate to the top.
Yeah.
And then when it wants water topping into the system, it can draw it from the bottom where there isn't any micro bubbles. So it deaerates the system. Because oxygen molecules, any micro bubbles in the system is what causes the iron oxide to form. So if you look here, this is old technology, all little pressure switches.